Okay, so today we're dealing with what's called anti-differentiation, which is finding antiderivatives. It's the opposite, right? Anti meaning roughly means opposite. So we're going to do the opposite of differentiation. Okay, so before we do that, you're going to see this little, looks like a little S. It's an integration symbol, right? We have all types of derivative symbols, right? F prime, y prime, dy dx, d over dx, right? All of those symbols mean derivatives, right? Well, integration also has symbols too. The big symbol is this little guy here, this guy here. And it always has a dx at the end. So anytime it's a integration problem, it'll have the integral, the sign for the integral, and then it'll have a little dx at the end. Okay? I'll explain what the dx means. Why is there a dx? Well, don't worry about that today. We'll figure it out, but not today. Okay? So you're going to see a lot of those symbols. Okay, so before we start, let's take what we know, right? So we know this. So we know, you don't have to write this part down, but I'm just going to jot down just what we know, right? If that's an original, if that's our original, right? We spent a whole semester doing this, right? Going this way. All right? So the derivative of x squared is 2x. Okay? That's differentiation. Today what we're going to do is anti-differentiation. Going backwards, yeah. So before we can do that, let's start with where we're comfortable with. We're comfortable with going the red arrow, right? The red arrow we've done, you guys have done that all semester, last semester, right? Okay, so what was the rule for going the red arrow way? What was the rule? It's the power rule, right? What was the rule for it though? Explain to me how we went.
You would put the power in the front, multiply it to the front.
Multiplication, good, keep going.
You would subtract the power by 1.
Good. So we had multiplication and subtraction, right? We had those two things, right? So this is the power rule. The power rule said whatever the power was at the beginning multiplies times what was already there, right? Whatever was already there. And then we subtract a power, right? That was the power rule. Right? Okay. So we just said, like Celeste just said, power rule for derivatives or differentiation had multiplication and subtraction, right? So what do you think the anti-derivative or anti-differentiation will have?
Division and addition.
It's going to have division and addition. Okay? So this guy is going to have division and addition to go from here to here. Question is, where is it going to have division and addition?
Division in the front, addition in the exponent.
So how do I make, using division and addition, how do I create a rule that's going to go from 2x to x squared?
Add 1 to the exponent.
So let's start there. Let's go really slow. First thing we need to do is add 1 to the exponent, right? That's where the addition's going to come in, right? So instead of n minus 1, it's going to be n plus 1. So let's write this down. All right? Where does the division come from? Okay, so we know how I go from x to the first power, right? Because this is 2x to the first power. We don't write it, but it's really that, right? So we know how we get the extra power. I add a power.
And you divide the front by the exponent.
There you go. So now where does the division come in? The division is we divide the whole thing by what?
Or by the exponent.
By the new exponent, right? The new exponent is n plus 1. That right there is the power rule for antiderivatives. It's got addition and it's got division. Multiplication, subtraction. Okay? So let's see if it works. If I start with 2x, it's got a 1 power, right? So if I give it another power, how many powers is it going to have?
2.
Okay. Now how do I get rid of that 2?
Divided by the new exponent.
Divide it by the new exponent. What was the new exponent? 2. So if I divide this guy by 2, it's going to be 1. Okay? So let's try it on another one. Let's say 5x to the third power. What would be the antiderivative for this guy? So, well, what does the rule say? So let's start with the power. Add 1 power, right? Divide, right? Divide that number in front by the new power. There you go. And you have a way of checking it, right? How can I check to see if this answer works? Find the derivative, and if it gives you that, your money. You're good. Okay? All right. Okay, so, yep, that's it. That's the power rule for antiderivatives. Most of the time, you're going to be using that. Right? Most of the time, you're going to be using that. Okay, so let me give you another one. What if I have, instead of, okay, so let's say x squared again. But x squared plus 2. We know the derivative would be 2x, right? So I know how to do the red. But using our power, using our rule, would it give me that? No, right? What wouldn't it give me? Which part would be lacking? The plus 2, right? So that's where the antiderivative rule kind of, I don't want to say it has a little bit of a flaw to it. Because there could be a constant that wasn't there. That was there that we can't account for. So what do? To fix that, we always put a plus c for constant after it. So anytime you take an antiderivative, you always have to put a plus c after it. Because there could have been a constant that I can't account for. Okay? So that's the power rule. Let me write it up here. So the power rule says x n plus 1 over n plus 1, and then I also always have to put a plus c after it. So anytime you do an antiderivative, anytime you use the power rule, I should say, anytime you use the power rule to find an antiderivative, you got to put a plus c after it. Okay?
Will it be different when you use like the other rules?
So here's the thing about integration. You know how for derivatives we had a power rule, quotient rule, product rule, chain rule, right? We had all those rules. With antiderivatives, there's only 2 rules. They don't have a quotient rule. They don't have a product rule. They have what's called U substitution, which is a version of chain rule. So the nice thing about antiderivatives is there's really 2 rules, and we'll do U substitution next week. So yeah, so we don't have. So that's what we're going to be dealing with today. How do we get around? What if I wanted to use the quotient rule or the product rule? Well, we can't use those for antiderivatives. We don't have one for antiderivatives, so we have to get around that. Okay. All right. So let's go. So let's start with this. So you notice that you see the notation says plus c. The plus c guy. Okay. That's where that comes from. Okay. So if 2x is the derivative, what was the original? Yep. Do the power rule, right? Power rule says add 1 power So that would be 2, right? And then divide by the new power. So that becomes a 1, so you have x squared plus c. Okay, what about x? I should put f of x. So we would use the power rule again, right? So the power rule says add 1 power. So it had 1 to begin with. So that means 2, and then I got to divide by 2, right? Plus c. You can leave it like that, or you can say 1/2 x squared plus c. Either of those is okay. This guy, what would be this guy? 1/3. 1/3 x power 3 plus c. What about d?
Will we ever know what C is? Like
Yes, yeah, we'll solve for c. Some of the problems we'll have us solve for c. Yeah, for sure. They'll give you enough information where you can solve for c. Actually, in the last 2 problems, I think, of these notes, we'll be able to solve for c. Yeah. So d. How could I, again, I don't have a quotient rule. There's no quotient rule here. I can't use a quotient rule for antiderivatives. So it's not like I can do that. I just have a power rule.
Is it just 0?
So keep going. So Macy,
So you would put the 1 on the bottom and give the x a negative exponent?
exactly. So it would be, another way to rewrite this would be what?
X to the negative 1?
1x to the negative 1 or just x to the negative 1, right? Good. Now I can use the power rule, right? So if I add a power, what would I have?
0.
That's okay, I can have 0 power, right? But then what does the power rule also say?
You have to divide the front.
That's where I run into the issue. I can have x to the 0, that's just 1, but I can't divide by 0, right? So this is the only time the power rule won't work. So I want you to think back. You guys actually know the answer. You guys actually know the answer. When did we ever get a derivative of this guy? Natural log, yeah, natural log. So this is so when we can't use the power rule,
Use log.
you just have to remember this one is the log, natural log of x. The antiderivative of 1 over x is the natural log, just like the derivative of natural log is 1 over x. Okay.
Will we put plus C too?
Plus c, sorry, yep. I forget that sometimes. Plus c. Okay. So yeah, just like when we were doing, like, how do you find derivative of the natural log? It was one of those things you just had to memorize, 1 over x. It's the same thing for this. The antiderivative of 1 over x is the natural log. Okay. This guy, how would I rewrite this guy?
Negative, or x to the negative 3.
X to negative 3, right? Which is x negative 3. Okay, let's use power rule. Add a power. Divide by that new power. I can divide by negative 2. That's a real number. So it would be negative 1/2 x to the negative 2, right? That means move it down. So it'd be negative 1 over 2x squared plus c. Yeah. Okay. So the only time I can't use the power rule is for 1 over x. 1 over x to the first power. Okay? Okay, so the bottom, integration rules. These are just common things. So the antiderivative of a is just a number. So if you have a number, so if it's like, so that it's talking about like the antiderivative of 4. It doesn't have a power, right? So you just give it a power. So it would just be, oops, it would just be a to the x plus c. If it doesn't have a letter,
Just give it a
just give it a letter, plus c, you're done. Number 2 is the power rule. That's the power rule. What happens if you have a power? Well, I add a power, I add 1 and divide by that new power, plus c. Number 3 is what we just saw. What happens if I have x to the negative 1? Becomes natural log of x plus c. Number 4 is what we call the sum and difference. So if you're integrating both, you can just separate it into 2 bigger parts. So you can just do the integral of f of x dx plus or minus the integral. You can break them up into 2 smaller problems is what I should say. And then you'd find the antiderivative of f of x, you'd find the antiderivative of g of x, and then add or subtract them together, whatever it was.
Why doesn't 4 and 5 have a d of x at the end?
Because they should. 4 should have a d of x, yep. That's another thing. I always forget about either this plus c or the d of x. dx. So right now the dx is kind of a nuisance. Why is it there? Why do we always have to write it? Next week you'll understand why it's important. It does have a job. Just right now, no, it doesn't. Okay, so number 5, what if you have something times a function? Well, you can actually move that guy to the front and then do the antiderivative. Okay. Number 6, the antiderivative of the derivative. What do you think that is?
Just the base f?
Just f, yeah. It's saying take 2 steps forward, now take 2 steps back. Where are you? The original.
Mr. Flores, for number 4 and 5, we wouldn't put plus c?
No, because we didn't actually find derivatives, or antiderivatives yet. I still have that symbol. If I still have that symbol, that means I haven't done it yet. All right, number 7, d over dx. What does d over dx mean? Find the derivative. So they want you to find the derivative of the antiderivative. That's just f of x again, yeah.
Would it be plus c or no?
Plus c, yeah. Yep. Okay. Sometimes you'll see the notation. Capital F of x. You're going to see this chapter, you're going to see the notation capital F. What does capital F mean? It's the antiderivative of f. So this is the antiderivative of f of x. You know how f prime is the derivative of f? Well, capital F is the antiderivative. It just means you went up instead of going down. Okay.
Mr. Flores, if we were to get like a number like in the front, would we simplify it or not?
You can, yeah. Yeah. Okay, so let's see. Examples. I threw a bunch of examples on here. 7x. There's 2 ways to do this. I can use the power rule right now, or you can move 7 to the front. So you can do it this way, or you can say, let's move 7 to the front and just find the antiderivative of x. Some of you probably wouldn't, most of you wouldn't do that. Most of you would just say, okay, 7x to the second power divided by 2. So you can do it that way, but most of you guys would probably just say, let's just use the power rule. What does the power rule say? Add a power, divide by that new power. So it would be 7 over 2 x squared plus c. Okay, do number 2. Number 2, add a power. So it's to the 4th power, right? Divide by whatever the new power is, plus c. Okay. Number 3 is 3 separate problems. So you're just finding the antiderivative of 2x, positive x squared, 3x squared, and negative 5x to the 4th. So the antiderivative of the purple one would be 2x squared divided by 2, right?
It's just x squared.
Which is just x squared, yeah. It would just be x squared. Plus the antiderivative of 3x squared.
1 x to the 3rd.
3, yeah, it would be 3x to the 3rd divided by 3, right? And then 5x to the 5th divided by 5 plus c. So all the coefficients reduce to 1. So really it's just x squared plus x cubed minus x to the 5th plus c. Okay. Number 4. Number 4 is a chain rule problem if we were finding derivatives, right? But we don't have a chain rule problem. So how do we do number 4? What's another way we could use just the power rule to do number 4?
Could you like solve it?
Multiply, yeah, multiply, right? Doesn't this mean 3x minus 1 times itself, right? So you just multiply. You use FOIL. You can use a 2x2 multiplication box, however you're more comfortable. First, outer, inner, last. So really it's 9x squared minus 3x plus 1. You can combine the negative 3's to make negative 6, or you can do that later. So it would be 9x to the 3rd divided by 3 minus 3x squared divided by 2. Same thing over here.
Why is x to the 3rd for 9? Oh.
Because it was x squared, yeah. And then 1. 1 doesn't have an x. So if it doesn't have an x, the antiderivative, we just give it an x. You can divide it by the new power, but it's just 1. So that would be 3x to the 3rd. I can combine these like terms here. These both are like terms. So negative 1.5 minus 1.5 is negative 3. X squared plus 1x plus c. All right. All right, so let's go to the next one. Okay, so this one looks like if you were doing derivatives, it looks like we would use the quotient rule, but we don't have a quotient rule. So we got to get around that. Well, what's the first thing I would do before I do anything? Change the square root, and I would do that again. That doesn't change. If I have a power rule, I can only use it if I have a power. So change the square root to 1/2 power, right? Dx. So I don't have a quotient rule. I can't throw this into the quotient rule because I don't have a quotient rule for antiderivatives. So how would I do it? Well, the top is a binomial, right? The bottom is a monomial. So each of the top is actually being divided by the bottom. So in other words, x is being divided by x to the 1/2. Positive 1 is being divided by x to the 1/2. I can simplify. This is 1, right? Subtract the powers. I get x to the 1/2. The other one I can't subtract the powers, but I can move up to make negative 1/2 power. Once I do that, now I can use the power rule. Add a power. So if I add a power to 1/2, how many powers do I have? 3/2, right? And then I got to divide by that new power. 3/2. If I add a power to negative 1/2, what do I have? Positive 1/2, right? And then I got to divide by that new power. Well, what's the rule with dividing by fractions? Instead of dividing by fractions, you multiply by the reciprocal. So what's the reciprocal of 3/2?
2/3.
So it's just multiply by 2/3. And multiply by 2/1, which is just 2. There you go. Yeah, so instead of dividing by a fraction, just multiply by the reciprocal. Skip that step. Skip this step here where you're dividing by fractions. Just, multiply by the reciprocal, 2/3, 2/1. Okay. Number 6 is similar. Change, give it a power. So what power would the first guy have? It's a subtraction, right? It's a binomial. 2 to the 1/3. So it would be 2y to the 1/3, good. And then 4y to the 1/4, right? Notice how this one doesn't say dx. It says dy. Why does it say dy? Because we're dealing with y's. Whatever the independent variable is, that's what it'll be. So this one was y's instead of x's, so that's why it's dy. Okay. Power rule. Add 1. If I add 1 to 1/3, what do I get? 4/3. And instead of dividing by 4/3, let's multiply times 3/4. Okay. And then over here, we get 4y to the 5/4. Instead of dividing by 5/4, let's multiply by 4/5.
Wait, why are we multiplying?
Because when you divide by fractions, you're really multiplying times the reciprocal. So if you're not comfortable, do this step. Do this step. I just skipped this step just because you guys have seen that before. That's why. Okay, so we got to multiply. So we get 6/4, which is the same as 3/2. Y to the 4/3. Minus. And then we get 16/5, so 16/5. Y to the 5/4 plus C. So again, like with almost everything in this class, the hardest part is not, that's probably the easiest part. Using the power rule is probably the easiest part. The hardest part is doing all the other stuff. Okay? So yeah, go ahead. If you guys, those of you that are going, go ahead. What we're going to do is just we're going to do some more practice. We're going to finish this tomorrow. We're going to finish these notes tomorrow. But that's really what we're just using the power rule. Next week, like I said, I'll introduce you to U substitution. U substitution is just their version of the chain rule. Okay. Okay, so flip over to the back. Okay, so these should all look familiar. All of these guys should look familiar. This guy, this guy, this guy, this guy, this guy, and this guy. Okay, so do me a favor right now. Take out your... So it's behind, the one behind the unit circle. We're going to use, we haven't really used the back side of the unit circle. We're going to do that definitely this chapter. Okay, so you're highlighted, I believe it's like a yellow or green. So go to the back side. I'm going to show you some things back there because we're going to definitely be using that stuff this chapter. So it should look like this. So the top is differentiation. 1 through 24 at the top is derivatives. That's what we did last semester. This semester, we are using this guy right here. Okay? So we've gone through a couple of these. This one, we did the rule. Some of these we've done already. These three, I think we've covered today. We talked about natural log a little bit. E we'll talk about later. But these are the ones we're going to focus on now. Where was it? I think these guys. Okay, so first one. Sine of x. What was the derivative of sine?
Cosine.
Cosine, right? It went like a circle, right? The derivative and for the derivatives, right? So like, I haven't showed you this in a while, but so let me write it up here. Like if we start with sine, right? The derivative is cosine. What's the derivative of that? Negative sine. And then what's the derivative of that? Negative cosine. And then the derivative of that takes me back to sine, right? Okay, so the go clockwise is the derivative. So how do you think we're going to find the antiderivative? Go backwards, right? So sine, what's the antiderivative of sine?
Negative cosine plus c.
There you go. Yep. Negative cosine of x plus c. What's the antiderivative of cosine?
Sine plus c.
Sine plus c. Secant squared,
Tangent.
right? It comes from tangent, right? Isn't the derivative of tangent secant squared? Well, what do you think the antiderivative of secant squared is going to be? Tangent of x plus c. Cosecant squared. Cosecant squared, the derivative of cotangent was negative cosecant squared. So the negative we dropped, right? So that means we need a negative cotangent here. Negative cotangent. What's derivative was secant x tangent x? So the antiderivative of secant x tangent x is just secant. Oops, plus c. I should always put a plus c here. And then the derivative of cosecant was negative cosecant x, cotangent x. I drop the negative. So because of that, I have to put a negative. Okay, these are all on here. These are all 8, 9, 14, 15, 16, 17. Those are all those. Okay? All right. So, some more examples. Antiderivative of 4 times sine of x. Well, the 4, we can just move to the front because it's just multiplying times sine of x. So really, we can rewrite it like this. What's the antiderivative of sine?
Negative cosine.
So that means it would be negative 4 cosine of x plus c. Done. Okay. Let's look at number 2. Number 2. So number 2 is a little, not tricky, but it's a little different. The reason it's different is because on the list from the page before, or right above this, is there anything that says cosecant squared? I have cosine. Was there any of these that said cosecant or cosine squared? No, just regular cosine, right? So I have to kind of manipulate it a little bit. So what I'm going to do first is I'm going to rewrite it. I'm going to put the 6 in the front, just like I did on the last one. That leaves 1 over cosine squared of x. One over cosine is also what? What is 1 over cosine? No. It's secant. 1 over cosine. 1 over cosine, let me write that down, is actually secant. Right? Well, 1 over cosine squared is what? Would be what? Secant squared. So it would be 6 times the antiderivative of secant squared of x. Secant squared I have on my list. Secant squared is number 3. I know the antiderivative of secant squared. What's the antiderivative of secant squared? Tangent. Number 3. Done. Okay. Let's see here. We'll do 2 more and we'll be done. We'll be done for today. The rest we'll finish tomorrow. Okay, so this guy here we're going to break up into 2 smaller problems. Since it's got a minus in between, I'm going to do 9 times cosine of x dx minus 4 times sine of x dx. I'm going to break up into 2 smaller problems. From there, you can move the 9 to the front. And you can move the 4 to the front. Now you got antiderivatives. The antiderivative of cosine is negative sine. So this one would be negative 9 sine of x.
Wouldn't it be positive sine? Because you have positive code.
Oh, yeah, you're right, yeah. Yeah, it's positive. Minus 4. The antiderivative of sine is negative cosine, right? So that means this guy needs a negative in front. Cosine of x plus c. So you get 9 sine of x plus 4 cosine of x plus c. Okay. Last one. Last one we'll do today, and then we'll finish the rest tomorrow. This guy here. Again, we don't have there's no quotient rule. There's no quotient rule, so we can't throw this into the quotient rule and find antiderivatives that way. Derivatives, yes, but not antiderivatives. So we're going to have to kind of change this around a little bit. So what I'm going to do is rewrite it, right? There's a negative 1, right? Isn't there a negative 1? I'm going to put the negative 1 in the front. That's where that negative comes from, right? The negative 1. I'm just going to move that guy to the front. So that leaves sine of x over cosine squared. So that means cosine of x times cosine of x. Well, I definitely have cosine and sine on my sheet, on my list. But I have to get rid of that division. So this is what I'm going to do. I'm going to break it up a little bit more. So negative 1 in front. I'm going to pair them up a little bit. I'm going to pair them up. I'm going to say sine of x can pair up with cosine of x. And then that leaves a cosine on the bottom, right? The reason I did that, what is sine of x divided by cosine of x? Tangent. And what is 1 over cosine of x? Not sine, secant. Yeah, it's actually secant. Does that look like something that's on my list
Yeah.
from the top of the page earlier?
Yeah.
It's secant tangent, right? And what's the antiderivative of secant tangent? I keep forgetting dx. Is secant, right? So this is negative 1 times secant of x plus c. Okay. So sometimes those can be a little tricky, but you always get ones that you can manipulate because you can manipulate sine and cosine and tangent and all those things. Okay. All right, we'll finish the rest. We don't have very much. We just have, I think, 2 examples left and we're done. So the rest tomorrow, I'll give you the practice so you guys can start on that. Because these will just take us about 10, 15 minutes. It won't take us that long. All right. All right.